Okay, identifying the components of a chemical equation. We've already talked about these. Here we've got a reaction where elemental magnesium is mixed with diatomic oxygen to produce magnesium oxide. So magnesium and oxygen produce magnesium oxide. This is a synthesis reaction. We are synthesizing magnesium oxide from magnesium and oxygen. So these two elements combined make that combined compound. Okay, so they give you a word bank here, and you're just supposed to write the words in the appropriate spot. Over here on this side, we have the reactants that we are mixing together, and over here we have the products. This is all kinds of stuff we covered before. This arrow sign means yields. And particularly today, we are going to be paying attention to subscripts and coefficients. They are different. Subscripts and coefficients are different. Subscripts, you remember, we had to add when we were making compounds, right? Because we had to, there was, depending on the oxidation numbers, there were so many particles of each that would combine. And so we had to keep track of that with subscripts. Coefficients now are multipliers. They refer to them as unit multipliers in the book. They are used in balancing the equation. So subscripts are used when we form compounds. Coefficients are used when we are balancing chemical equations. This is like one of the most important things that I can tell you. You cannot change a subscript in order to balance a chemical equation. The only thing that you can do is add or change coefficients. Okay, so that's my big point. Don't mess with the subscripts, all right? Because you went to a lot of work to figure out what those were in the first place. You can't change them. If you change the subscript, you are actually changing the compound. We're not changing the compounds, we're just balancing the chemical equation. Okay, so let me zoom back out here. And now let's work with our equations that we have on the back. All right, so let me put Harry Bear over there. And the way I'm just going to go ahead and write this. Again, I'm going to post this practice sheet with the recording after office hours so that you can practice on some of this. Okay, so the first one is the famous equation H2. And when we do these, we are going to leave a little bit of space for a coefficient in front. Plus O2 is going to produce or yield some quantity of H2O. Now, I said this is a very famous equation because this is what the Martian did when he went to Mars. And if you remember the movie, the guy was stranded on Mars. And he needed to produce water in order to grow food. What he had with him on board on the Mars outpost is he had hydrogen gas and oxygen gas. Well, if you combine hydrogen gas and oxygen gas, you get water because there's hydrogen and oxygen and water. Now, if you look at this equation, this should begin to bother you and you should say, this is not balanced. I need to balance this. What I'm going to do today is I'm going to show you my strategy for balancing. Now, like I said, there's probably some of you out there who can just look at this and know what to do. Others of us need a strategy. Okay. So my strategy is to right underneath the arrow, I want you to list the elements that are involved in the reaction in a vertical column. And let's just do it as we encounter those elements from left to right. And we only need to do the reactant side because whatever's on the product side is in the reactant side. So the first element that we come to in the reaction is hydrogen, and we are going to write that directly underneath the arrow. then the next element that we come to in the chemical reaction equation is oxygen, and we're going to write that right underneath. Now what we're doing is we're setting up basically a balance sheet. We're gonna write things on either side here. Okay? So now that we've listed all the elements, it's hydrogen and oxygen on this side, hydrogen and oxygen on this side, hydrogen and oxygen. So what we're going to do is we're going to count the number of atoms. All right, the subscript tells us that there are 2 hydrogen atoms here in this term. So I'm going to write a 2 right here. Right? Now I'm going to go to the other side and I'm going to say, well, how many hydrogen atoms are on this side? Well, again, the subscript tells us that there are 2. Okay? So right now we see that the hydrogens are in balance. There's as many on this side as there are on this side. Now, let's look at oxygen. All right, the subscript tells us that there's 2 oxygen on this side. So I write the 2 over here. And over here, there's only 1 oxygen. Okay? So I have to write a 1 right here. Obviously, this equation is not in balance. The hydrogens are, but the oxygens are not. So there's something that we have to do in order to balance this chemical equation. So what I say is, okay, well, what's out of balance? Well, we've got to get the waters in balance. Now, I also said that the only thing that you can do is to add subscripts. I mean, well, slap myself. The only thing that you can do is change coefficients. Right? So I'm going to change colors here because this is kind of like the next step in my strategy. I'm going to put a coefficient in front of this term, and the reason that I put a 2 there is I want to get 2 oxygen so that they balance, right? So now I start the process over again. After I've added the coefficients, right? Now I'm going to start my process again. All right, how many hydrogens do I have on this side? Well, I haven't changed this side, so there's still 2. How many hydrogens on this side? Remember that this 2 coefficient multiplies everything in the term that follows. So it multiplies the 2 hydrogen that I have here by 2. 2 times 2 is now 4. Okay? And looking at the oxygen, I've got 2 oxygen over here. I haven't changed anything, but now, yes, this is what I set out to do. This is what I wanted to accomplish. I now have 2 oxygen. So, hey, happy day. My oxygens are now in balance. But in the process of balancing my oxygens, I actually threw my hydrogens out of balance. I got 2 over here and 4 over here now. Some of you are looking at that and say, well, Mr. A, it would be real easy to balance those hydrogens if you just put I'm going to change colors again because this is like another step. If you just put a 2 over here. Okay? Now see what that did? This hydrogen's all by itself, so putting that coefficient there only changed the number of hydrogens. Now I don't have 2 hydrogens, I have 4 hydrogens. So 4 hydrogens on this side, 4 hydrogens on this side, 2 oxygens on this side, 2 oxygens on this side. I've balanced the chemical equation. Okay, so that is my strategy applied to one example. Right? Let's do another one. I'll work a little bit more quickly because I'm not having to explain every single detail. Number 2 on the worksheet is another reaction that you might be familiar with. So I'm going to leave a space for a coefficient, and I'm going to write the chemical formula for peroxide. Looks very similar to water, but it's not. But actually, peroxide will break down into water and oxygen if you expose it to sunlight. Okay, so here's my next equation. Is it in balance? Maybe I give you an equation and it's already in balance. Let's check and see. The way we check and see is, again, I want you to write the elements down as you encounter them from left to right. So this one, this formula, this equation only involves hydrogen and oxygen again. This equation, by the way, peroxide is that stuff that you keep in the brown bottle and in the medicine cabinet, in the bathroom, or in the first aid kit. It's in a brown bottle because if you expose it to sunlight, that makes this reaction go forward, and the peroxide will turn into water and oxygen gas. So if it's been sitting in there for a couple of years and then you go to use it and it doesn't fizz anymore, that's because what you did was you just put water on your cut because it's no longer peroxide. It has decomposed, as we say. Okay? Whoa, did my, I got to think my scene just froze there for a second. Okay, we're back. Okay, so let's go on with the strategy. I have got 2 hydrogen on this side, and I've got 2 hydrogen on this side. I've got 2 oxygen on this side, and I have got, 3 oxygen on this side. It's not in balance because I've got the 1 oxygen with the water, and I've got 2 oxygens with this diatomic oxygen. I hope that you watched the video on the diatomics, Tyler DeWitt's video on diatomics. It explains to you why sometimes in a compound we have elemental oxygen involved in bonding with other elements, but if we have oxygen all by itself, it is going to find another oxygen and partner up. That's how we don't see elemental oxygen floating around in the air. We always see them bonded together. Okay, so now let's go through the process of balancing this chemical equation. Again, I look for what's out of balance. The oxygens are out of balance. There, it seems, so on the side that's lower, so there's only 2 oxygen over here. Let's try to bump that up. So with a different color, I'm going to say, okay, I can't change the coefficients. Yeah, someone could say, well, Mr. A, why couldn't you just make this a 3 over here? Well, I can't change the subscripts, but I can add a coefficient to this side. Okay, now because I added a 2 there, that's going to change everything in the term that follows. So I no longer have just 2 hydrogens, I've got 4 hydrogens. I no longer have 2 oxygens on this side, I've got 4 oxygens on this side. And whoa, I'm still not in balance. Okay, so I'm going to have to do something else. All right, this is a 4 and this is a 3. Let's see, what could I do to, and my hydrogens aren't in balance anymore either. Well, let's see, I could put 2 here, and then that would increase my number of hydrogen. Okay, so let's see. Now let's go ahead and see how that affects things. So now I've got 4 hydrogen over here, and that's going to make it 2 waters and 2 oxygen here and 2 oxygen here. So now, oh, look, I just did it. 4 and 4 and 4 and 4. Happy day. I thought I was going to get in trouble there, but sometimes things just fall out, right? So this is my strategy for for balancing chemical equations. I think we have time for one more. Those 2 were very similar in that they both involved hydrogen and oxygen. It was an equation which just had 2 elements. Let's, dare I say, we go down and look at number 8. This one was one that gave me some trouble yesterday, but we eventually got to an answer. So let's see, let's take number 8. I'm going to leave room for a coefficient, and I'm going to take elemental iron, and I'm going to put it in water. And that is going to produce iron oxide, leave room for coefficient. That is going to produce iron oxide, Fe3O4, plus, leave room for a coefficient, hydrogen gas. All right, looks like I need to move my little thing here. Okay, and hydrogen gas. Wow, so this is a crazy equation. This is iron like an iron nail. This is water like water. So if you put an iron nail in water, it's going to rust and produce a little bit of gas along the way. This is iron oxide. This is what rust is. Okay, so now this equation has 1, 2, 3 elements involved. So I'm going to write iron, hydrogen, and oxygen. Those are my symbols for all the atoms that are involved in the process. And now I'm going to write what my initial conditions are. There's 1 iron over here, subscript 3, 3 irons over here. Hydrogens, I've got 2 hydrogens over here. I've got 2 hydrogens over here. I've got 1 oxygen over here, and I've got 4 oxygen over here. All right, quickly now, I'm just going to work left to right. I'm going to try to balance out these irons. There's only 1 over here, but there's 3. But look, that iron is all by itself, so I can just put a 3 here and change only that. So now my irons are in balance. The irons are in balance, the hydrogens are in balance, but my oxygens are not. I need 4 oxygens on this side, so why don't I just put a coefficient of 4 in that term? So that will give me 4, oops, sorry. Don't ever erase. What I want you to do is to scratch out. And the reason is that you might have to backtrack and you won't remember what was there in the first place. So that's why I scratch out and then write the new number. Okay, so let's rebalance. 3 irons, that hasn't changed. As far as the hydrogens go, now I have 4 hydrogen on this side. 2 times 2 is 4 hydrogens on this side. And 4, no. 2 times 4 is 8, Mr. A. What's the matter with you, right? 8 hydrogens on this side and 4 oxygens, okay? 2 hydrogen, 4 oxygen, okay. All right, the irons are in balance, the oxygens are in balance, but in doing that, I threw off the hydrogen. So you sometimes it kind of feels like you're chasing your tail, but trust me, they usually fall out. Okay, so I'm gonna have to change colors again because I need to balance out these hydrogens. Luckily, hydrogen's all by itself down here. So in order to get an 8, I just need to have a coefficient of 4 here in front of my hydrogen. 2 times 4 is 8, and everything now comes into balance, right? Okay, that went a lot better than it did yesterday because sometimes it depends on there is a strategy to balancing these chemical equations. Yesterday, I think I started putting a coefficient here, and I ended up with like 6 and 8 and 2 and 8 here, which it eventually balanced, but then I had to reduce everything, divide everything by 2 in order to get it to its lowest multiplier. I don't know. It was, like I said, it was a big mess. But anyway, this was a lot better. Okay. Yes, I guess that's a good point. If you balance something and say that you got 6, 8, 2, and 8 as coefficients. I'm sorry, I wrote that too high, didn't I? Let me bring this down. Right. If you got 6, 8, 2, and 8, you're not supposed to leave it like that. You would say, oh, listen, I could divide everything by 2. And you're supposed to divide it. There's a name for that in math. I forget what it is. Least common multiplier or something like that. You're supposed to reduce your answer. Okay. All right. But I didn't have to do that today. Okay. I'm going to put this away. And did everybody kind of follow that? Do you have any questions for me before I move the screen? Okay. Well, good. I must have explained that pretty well. I'll tell you what I'll do. I will post this recording on the, before I stop the recording, just let me say, so what I did 3 problems of the 10 that were on the worksheet. And that number 8 that I did was pretty hard. There's a couple of challenging ones. There's a lot of easy ones just to build your confidence. I want you to go ahead and practice doing those when we're done today. And if you forget how to do my strategy, well, the recording will be there. Okay, so I'll go ahead and stop.